Hello, class. Back to do a couple more examples of u-substitution with definite integrals, just to make sure you have a lot of variety to look at as you're working through the homework. First one for today, I want to look at the integral from 0 to the square root of pi of x times the cosine of x squared dx. So I want to try and figure out what my u is going to be, and I think I'm going to settle on u is x squared. So then du is going to be 2x dx. So this is my translation unit. I'm going to go ahead and put an x equals in front of the limits to remind me that I have to translate those. And I'm going to go ahead and just move everything around so that it'll be easy to translate. So there'll be an x equals 0, x equals square root of pi, cosine of x squared, and I'll make my 2x dx, and I have to pay for that 2 with a 1/2 out front. Okay, so now everything is primed to translate. So this becomes 1/2 the integral of the cosine of u du, and x equals 0. That gets translated via this to, well, u equals 0. And x equals square root of pi. That gets translated to u equals pi, because the square root of pi squared is pi. Sorry, u equals 0 to u equals pi. Okay, so this is 1/2 times, and so the integral of cosine of u is sine of u, and we're evaluating this as u goes from 0 to pi, which is 1/2 of sine of pi minus 1/2 of sine of 0. But both of these are 0, so we get that, in fact, the value of this integral is precisely 0. Okay. And do one more. And then hopefully this will be a good enough sampling for you to look through as you work on these. So let's do the integral from 3 to 4 of x divided by the square root of 25 minus x squared dx. So I'm going to take my u here to be 25 minus x squared. So then my du is minus 2x dx. I'm going to move some stuff around. So this is the integral from x equals 3 to x equals 4 of 1 over 25 minus x squared with a square root over it times minus 2x dx. Okay, but I needed to make a minus 2 that I didn't have, so that means I need to also have a minus 1/2, because minus 2 times minus 1/2 is 1. So, as I like to say, I'm paying for the minus 2 with a minus 1/2 out front. Okay, and now I'm set to translate everything. So this is equal now to minus 1/2 times the integral of 1 over the square root of u du. Okay, and so x equals 4. That gets translated to u equals, okay, 25 minus 16. That gets translated to u equals 9. And x equals 3. I don't know why I did this backwards. Whatever. X equals 3, that gets translated to 25 minus 3 squared, which is 16. Okay. So this becomes the integral from u equals 16 to u equals 9. Okay. Note something happened here. Namely, the thing that happened that might concern you is that our integral is now backwards. Namely, always when we do this, we have the lower x and then the higher x. But here, because of the way u worked, we actually flipped things around. Okay. But I want to remind you what we said in a much, much, much earlier video, which is that if you're ever faced with minus the integral from b to a of f of x dx, that's the same thing as the integral from a to b of f of x dx. So in other words, you can flip the limits to going back in the correct direction. It just costs you a minus sign. Conveniently, we already have a minus sign, so I can just drop that minus sign and rewrite this as 1/2 the integral from u equals 9 to u equals 16 of 1 over the square root of u du. Okay. Now, brief aside, what would have happened if we had not noticed that the integral had gotten flipped, and I just proceeded and just done the problem without ever thinking about that? And the answer is nothing would have happened. You'd have gotten the right answer. Math would have done it right for you as long as you remembered that you put the limit at the top first and then subtract the limit at the bottom. So it is not, strictly speaking, necessary in any way to flip this around. Just if you're so used to looking at these things in the correct order and thinking about them in the correct order, this will help keep life more straightforward for you so you can think correctly about whether the integral is going to be positive or negative and all of that kind of thing. But anyway, I just wanted to alert you that the reason why we talked about this integral flipping at all, rather than me just saying I'll always write them in the correct order, is that sometimes, very rarely, but sometimes, when you're doing a u-substitution question like this, you end up actually inverting the order of the limits, and so you have to know how to deal with that. Okay, but let's finish the problem now that we've had this long diversion. Namely, 1 over the square root of u, that's u to the minus 1/2. So this is going to be 1/2 times u to the plus 1/2 divided by plus 1/2, evaluated as u goes from 9 to u equals 16. Okay, so 1/2 times 1/2 divided by 1/2, that's just u to the 1/2. Evaluated as u goes from 9 to 16. So that is to say this is the square root of 16 minus the square root of 9, which is to say at the end of the day, this is exactly equal to 1. Okay, I'm going to wrap up this video for now. In the next video, I'm going to talk about using all the integral stuff we've done so far to find some more areas of shaded regions, much like what we did last week. But we'll learn one more formula to help with that. But until next time, be well.